Alright, so what percentage of the volume of the cylinder is not occupied by the tennis ball? If the, I'm going to mark out that cylinder, if the height of the cylinder is 24 inches. So therefore 24 goes from here to here. So I now know that each ball is 6 in diameter, 6 in diameter, 6 in diameter, and 6 in diameter. Okay? But when I look at my formula, so if I do the volume of the cylinder, that is pi r squared h. And if I do the volume of the sphere, because I need to find a percentage, so I need to do the whole thing and over the part that is not filled in. So I need to know the volume of both of the objects, and this one will be 4/3 pi r cubed. So in both of these, I need to find the radius. The 24 will work for the height in this one, but I need radius, so I have to divide it and get the diameters, and then I'll divide one more time and get the actual radius of each one. 3, 3, 3 and 3, 3 and 3. So, volume, pi 3 squared times my height of 24. This gives me pi 3 squared is 9 times 24. 9 times 24 is 216 pi. So now the volume of the sphere. So this is the volume for one. But if I look, I know I actually have 4 of these. So I need to put a 4 out here in front. My radius is still 3. So I have 4 times 4/3 pi times 9. Now, I know that 4, 4, pi, and 9 can all be multiplied together because this is like over 1, over 1, and over 1. So when I multiply fractions, I just multiply all the numerators straight across. And so that gives me 432 pi over, multiply all the denominators, that gives me 3. So this is 144 pi. So I need the percentage that is not being occupied. So this is the total minus what is being occupied, which then gives me 72 pi. So this is what's not occupied, but because I need the percentage, I need what's not occupied divided by the entire thing. I can cancel out my pi's, and 72 over 216 actually is 0.3. We're heating. So this will be 33.333% as we round to the thousandth. Yours doesn't say this, but I incorporated this later. Now suppose the radius of one sphere is 4. If the balls were melted down into the cylinder, how many complete balls would fit into the cylinder? So once again, I need the volume of the cylinder, which is pi r squared h. I also need the volume of the sphere, which is 4/3 pi r cubed. So I know that the radius of one sphere is 4, so I can go ahead and put in 4 for my radius. But if I go over here and I do my radius is 4, that means that the diameter from here to here is 8. So therefore, if the diameter is 8 and I have 4 of them, I know that my height is 32. So I'm going to go ahead and put in 32 right here. So when I multiply, this gives me pi times 16 times 32, which then gives me 512 pi. Now go over to my cylinder, and I have 4/3 pi. R is 4. cubed. So this gives me 4/3 pi times 64. And this gives me 4 times 64 is 256 pi over 3. Now, to decide how many things will melt down, I take the total volume that I have and I divide it by the volume, of 1. So now I have a fraction divided by a fraction. So how do you divide this? I'm going to take 512 pi times 3 over 256 pi. So really what I'm doing is multiplying two fractions here. I'm going to put that over 1. Put a pi on the top and a pi on the bottom. 512 and 256, I can cross reduce. 256 goes into 512 two times. This gives me 2 times 3. My answer is 6 balls. Alright, take a look back over this. Make sure it makes sense.